Okay. Oops, wrong slide. Okay, now let's say we're given points and we have to write a quadratic. The best way to go about it is to use vertex form. So if you're given the vertex, you're going to plug that in for h and k, and then you have to be given another point, which you could plug in for x and y, and that'll help you solve for a leading coefficient a. Alright, if you're given 3 points, then you could set up a system of equations, which we'll learn later on. So let's try it. Let's write the function of a quadratic through the point 2, 3, and also through the point 4, -1, where that's the vertex. So we're going to start off with the vertex here. Alright, so we're going to do f of x is equal to some coefficient times x minus 4 squared minus 1. Okay, so we're 2/3 of the way done. We got our vertex plugged in. Remember, we subtract the x-coordinate of the vertex from x, so that's why it's x minus 4, but then add the y-coordinate of the vertex to x minus h squared, so that's why it's a -1 out there. Alright, now we have to find a, so we're going to find a by plugging in a point. So, I'm going to write it like this to show you what I mean. Our point is going to be x is 2, so when x is 2, f of x, y equals 3. So now we have to solve this out here. So we're going to get a times -2 squared minus 1 equals 3. So we can add 1 to both sides and we get 4. And then -2 squared is just 4. So you can divide that on both sides and we get a is 1. So if we plug a 1 right there, that is our function. F of x equals, you don't even need to say the 1, just x minus 4 squared minus 1. So if we were graphing this, we would go 4 to the right, down 1, there's our vertex, and then that's what a sketch of our graph would look like. It would be better if you found another point, and then went from there to make it more accurate, but that's fine for this question here, just sketch it out. Now if you did have to find another point, I would say plug something easy in, like 0. So let's say f of 0, the y-intercept, would be at 0 minus 4 squared minus 1. So that would be 16 minus 1 is 15. So this would have a, I know it's not really drawn that great, but it would have a y-intercept of 0, 15, which means it would have another point at 8, 15, because it's going to be, this parabola is symmetric over this line. So if there's a point 4 to the right at 0, 15, there's going to be 4 to the left of the axis of symmetry, 8, 15. I mixed up my left and right there, but that's okay. Okay, so just a quick summary of everything that we've learned in this video series. Okay, the vertex of the graph, if you have a function in standard form, is going to be at the x-coordinate -b over 2a, and then the y-coordinate is what you get when you plug that in for x. So we're going to do -b over 2a to see what the x is, then plug that in for x, and then whatever this all equals is the y-coordinate. Alright, if a is positive, the minimum value is going to be the y-coordinate of the vertex. If a is negative, then it's facing down. The maximum point is going to be the vertex, and the maximum value that the function can equal is going to be the y-coordinate of the vertex. You could find zeros by doing the quadratic formula, assuming that this is set equal to 0 and in standard form. And then if you look at these zeros, if you just don't add or subtract a discriminant, you get -b over 2a. So if you don't add or subtract that discriminant, you're right in the middle, which is why the x-coordinate of the vertex is going to be at -b over 2a. Alright, to find y-coordinates, y-intercepts, just plug in 0 for x and solve for y, and it's usually pretty easy. And with all that information, you know, if you have the y-intercept, you can find a buddy point pretty easily. With all that information, that's how you could go about graphing quadratic functions. Alright, that's it. Thanks for watching.